Hello and a very warm welcome here to the Parker booth at Bauma 2025. Parker is proud to be the global leader in motion and control technologies. And the motto here at the booth is technology inside that moves your world. The world we're talking about here at Bauma is giant machinery outside, and Parker is the hidden champion inside those very big machines. Here at the Parker Theatre, we have our experts brought here from all over the world to share their insights on the 4 key themes that we see driving the industry. And those are clean tech, electrification, digitalization, and mobile hydraulics. And it is now my pleasure to introduce our speakers for our topic on hybrid system architecture. First up, all the way from the US, I'm delighted to welcome, he currently heads the global electrification strategy, both for on-road and off-road vehicles at Parker's Motion Systems Group. Very warm welcome, Chris Griffin.
Thank you.
Great to have you here. Thank you. And all the way from Sweden, where he is sales development engineer for mobile systems. And there you initiate and lead customer projects in electrification and hydraulics, efficient hydraulics all across Europe. So very warm welcome also to you, Peter Sjovag. And I hope I got that right, Peter Sjovag. Lovely to have you here as well. Thank you for joining me. So let's start big picture. What is a hybrid solution in the context of off-road equipment? Chris?
Well, I think a lot of what we see here at Bauma and at other exhibitions that are similar to this is a lot of fully electric equipment. So you've removed the internal combustion engine, you've put a battery in there, and everything's being driven by that battery. But there are also economic use cases where it may make sense for multiple reasons to retain that internal combustion engine, but add electric components or systems to do some of the work or to perform some of the functions to reduce, fuel. It does allow you to reduce emissions, not to zero, but it does allow you to do that. And it also allows you to do things in a quiet mode as well, where you're not running a large diesel engine, but you're still performing work.
Can you give us some examples where that is a good idea to have that?
Yeah, a good example would be for an aerial lift truck for a utility company. So here in the U.S., or not here, but over in the U.S., we have a lot of hurricanes. So a good example would be, you're going out to repair utility lines, maybe in a residential area, but there's no power. And so you don't have any charging infrastructure to have a fully electric vehicle. So you use that diesel engine to drive out to the site, and then you can turn off the engine, turn on the electrics, and then the operators that are performing the work can actually hear each other, and they can operate more safely, and they're also not bothering people in the area. So it really gives them an opportunity to do their work in a more safe way.
Okay. What would you say, Peter, in the off-road sector? What's a good example of a hybrid solution that makes sense? And I think you've brought slides as well. Do we need to click to that one?
So this is a good picture of an electric wheel loader. So as you see here, we have a battery, we have inverters to drive the pumps, we have inverters to drive the transmission of the machine. I think what's maybe very optimistic in this picture, that is the size of the battery. It looks really small, and it's a lot of space available in the back of that machine. And in a real machine, that full engine compartment where you normally would have the engine, that's where the whole battery would be occupy the space. But if you use this machine in a remote area, a rural area, then it may not be possible to have a grid supply to the machine and charge the machine. Mm-hmm. And then I think it would make sense to have a hybrid instead. Yep. So you add the diesel engine, maybe a smaller one, smaller size compared to what you would use if you don't have a hybrid machine. And you also attach a generator to the machine. And then it gives you a lot of benefits to this type of application. It becomes more efficient because you can remove the torque converter in the machine. So even if you still have a combustion engine, you reduce emissions with this machine.
Okay, so you said rural areas where you don't have access to the power grid. Can you give us some real project examples of the kinds of machines where it's working? It's a great solution.
Yeah, because the nature, we are at the construction exhibition, and the whole purpose with a construction machine, that is to build infrastructure. So that means if you start to build a new highway or do a new city, you don't have the infrastructure. So then it makes sense to have a more clean machine, but you need to make sure that you get the energy to that place.
And a lot of the energy that's consumed, that would be consumed by that battery, is just getting the machine to the point where it has to do work. So it may make sense in a lot of cases to retain that internal combustion engine just to get it from point A to point B. And then when it's just going to be running all day long, then you switch over to an electric system. And it's not emitting CO2 at that point.
Okay, should we ask the audience, is there anyone here working on hybrid architecture? Anyone who knows these challenges? Or fully electric, even? I see the gentleman there at the back. Okay, he's working on it. So why are we talking about hybrids when so much of the investment is in electric battery vehicles?
Well, I think one of the reasons is electric vehicles are very expensive. They're very complicated, and it requires, a high level of, engineering support to bring those types of systems in, into production and to sell to your customers. And, for a lot of folks, hybrid is sort of an interim step. So you can maybe take a portion of what your machine is doing and electrify that and kind of bring your organization through its journey. And the other, advantage of it is it's also an interim step to getting to zero emissions, but also having an economically feasible product. So, if you're able to downsize the size of the engine, you may be able to get it into a lower emissions category. So it's okay to operate. But then you can do a lot of the heavy work without emitting CO2.
So compared to on-road, would you say hybrid makes more sense in the mobile machinery and off-road applications industry? Chris, because you have experience with both.
Yeah, I mean, I think it makes sense in both. I don't know that one is better than the other. I mean, I think Peter's example of doing construction where there isn't a grid, I think that's an excellent use case. And I think in the on-road space, particularly with work trucks, things like refuse trucks or aerial lift trucks, like I talked about earlier, there's an excellent use case there as well.
Okay, what are the challenges in implementing a hybrid architecture?
That's a good question. I think if you look at this picture, I think it's obvious it's a lot of components, because you still have your combustion engine, you need your cooling system, but you're also adding the electrification components. So that means you add all the components in one machine. And as we talked about before, that look at Bauma, big machines, and you think it's easy to fit all the components in the machine, but that is not the case. Both from a space constraint, but also the weight of the machine is a big constraint normally. So one challenge is just to fit everything on the machine itself. And then another thing that is important to talk about, that is especially talking about the serial hybrid. So that means that you have a quite long range of components. It's a big chain of events that needs to happen. So if you want to move the cylinder with the valves, then you need to pressurize your pump, you need to drive your motor, and you need to control your inverter to get the energy. And if you only have an electric machine, then you would stop there at the energy storage. But now we also add the generator and the diesel engine. So it's a long chain of events that happens in the machine. So you really need to take care of your lag, how quickly you respond in the machine, especially looking at the diesel engine side.
Yeah, the interaction between the internal combustion engine and the electric system has to be very closely coordinated and timed. And that often requires getting into the engine's software and making modifications so that it can interact properly with the electric system.
Yeah.
So how does Parker support its customers in hybrid systems? Why is Parker particularly good as a partner for designing hybrid systems?
I think that's a really good question. And we both work on the system side, supporting our customers, and we have a really nice offering, I think. A lot of components that are included in the machine, and working both with our application experts and our product experts, and really put all these components together. I think that's really nice, and we have.
And I would also say that our offering is designed to be very flexible and very scalable. So for the folks that are here on the stand and looking at our products, we're able to operate at a very wide range of voltages, a very wide range of power supplies. Good example for hybrid is when it's not a fully electric system, it often makes sense to operate that at low voltage, so 100 volts or less. The safety considerations are different. It's a little bit easier to work with, and the components are less expensive typically and more readily available, especially batteries. So we're able to support that, but we can also support extremely high voltage systems that would require higher power and larger battery systems as well.
Yeah. So I think if we look at a lot of the common components we use for electrification, for us, the main components are our inverter, the GVI inverter, and we also have our GVM motor. And we combine this with the other components we have in the system, the thermal management, we have our control system. And if you want to do a really efficient system, we also look at the hydraulics, because there are possibilities to make that more efficient. You can do energy recovery to also not only recover energy when you're braking the machine or the transmission, but you can also recover energy from the hydraulic system. And it's by combining all this, and I think that's where we're also most successful, when we're really working with all the components in the system, not only separate components.
And how do you collaborate at Parker to make sure that all works well together?
Well, we have system application engineering teams here in Europe, also in the United States and Asia as well. And, they're trained and their experience allows them to work with different parts of Parker, because it's a big company. We make lots of different products, and we're able to bring all those together into a system. And we work very collaboratively with our customers. So it's typically a very close engineer-to-engineer relationship. So we're sharing data and we're iterating as we develop a solution. So it's really these system application engineering teams that we make available to our customers that enable us to solve these applications.
So a standard solution, is that something that customers usually want, or do they always want a tailor-made solution?
I think in general, everyone would like a standard solution. Mm-hmm. Easy, you know exactly what you get, but that is not the reality normally. Yeah. We try to do it. One good example, what we have here on the screen now, is the yellow mark products, which is, if you put that in machine, especially with the configured e-pump, we create something we call the EPTO system. So this is not only separate components, it's components that we put together in one box. So we have the inverter, the motor, the pump, the control system, the cooler, and then we can send that to the customer for easy installation in the machine. I think that is something that most of our customers really like, to get that in one box.
Okay. Is that what you're showcasing here at bauma?
Yeah, we are showcasing our EPTO systems. We've basically done the engineering ahead of time, right? So we don't have to spend the time choosing components. There's a very basic bill of materials that we can start from. But every machine is different. And, certainly at the prototype stage, we can use those standard solutions. But, as a project progresses, maybe it goes into production, certainly we have to think about how we need to adapt that to make it perfect for the customer's machine.
Yeah.
Okay. So, Chris, you see examples on the automotive market. Regarding electric versus hybrid solutions, what can the mobile and off-road sector learn from the automotive market?
Well, I think what we've seen in the automotive market is, hybrids have become a very viable alternative to full electric, especially as we've had a lot of challenges with charging infrastructure. Certainly in the United States, it's a big country, but I think we have it here in Europe as well. And, so for especially for folks that have to drive long distances, a hybrid solution is a good solution. And I think we have off-road equipment that fits that criteria as well. Where, if there isn't an infrastructure available, but you want to be able to take advantage of some of the capabilities of an electrified system, having an internal combustion engine to as I said earlier, get from point A to point B is a good step in that direction.
Anything that you think that the off-road sector can learn from automotive in hybrid architecture?
Yeah, I think it's a lot of people at the moment they are afraid of range anxiety, for example. Will the car go enough distance or not? Hybrid could be an excellent combination of that. You are low emission when you are in the city. When you go out driving highway, you have the range you want. So it's this combination. I think what we will see on a lot of the machines here at the exhibition is that you adopt the machine where you want to use it. If you want to be in the city, you have one solution. If you want to be in a rural area, you have one solution. So it becomes even more adopted to where you're actually using the machine.
Mm-hmm. And do you have any data as far as if customers go hybrid, how much are they using the diesel engine and how much are they using the electric? Is it a question of habit then, or we'll just fill the tank and continue as usual? Or?
I think that is one of the really fun things with the application engineering, because what we have done last almost 20 years now working with electrification, that is to really work close with the OEMs and explore the duty cycle. We go to the machine, we put a lot of sensors on it, we really learn how the machine is operating. Mm-hmm. And when you're analyzing that data, then that's why you get a lot of ideas, new ideas, how to make the machine more efficient. Yeah. But it also tells you, should I have a big energy storage electric, or can we manage with a diesel, or should it be the opposite? So it's each machine is different, I think.
Yeah.
Okay, you've got to a good point with the successful project with the OEM. What's the key to that for you?
I think I really like being here at Bauma because I'm normally engaged in this early phase of the project.
Right.
You talk with the customer; they have an idea what they want to do, but maybe they don't know exactly what solution they want. And then to have this communication with and dialogue with the customer, to find out and explore together. They know their machine normally. We know our products. Yeah. But what is the best solution? We really need to discuss that together as a team. And the more open, the more honest you are about that, the easier it is to find a good solution.
Okay. What top tips would you have for your customers about successful cooperation?
I think working together, but also learning together. And I think if we approach it from that direction, I think you have a higher chance of success. If anyone here at Bauma tells you they have all this electrification stuff figured out, they're lying, because we're all learning, and there's every day there's a different kind of machine that's being electrified. So we're learning different ways of doing it, and that's probably the most fun part, I think, for folks that are doing application engineering is to work with a customer and solve a complex problem together, and that's what we try to do at Parker.
Okay, thank you very much. So I'll open the questions to the floor. We've got a couple of minutes time. Would anyone like to ask our experts a question on hybrid architecture? Anything that you've experienced, either as a design engineer or from the procurement side? Oh, fantastic. Could you use the microphone so we can all hear you loud and clear? Thank you.
So I have a question, and it's relating to work function or the travel function of the machine. Where is the sort of largest energy consumption? Is it from the movement, or is it from the particular work function of it?
Good point. So comparison between work function and travel function.
I think in general, I would say the travel function takes a lot of energy.
Yeah.
So driving around, a lot of machines, you do much more driving. Maybe you do 70% driving and then you operate for 30%. And that could be like a backhoe loader, for example, or a truck crane, for example. Then on the other side, you have like an excavator. It travels probably 20% and do the work function 80%. Yeah. So it really, again, depends on the machine. And that's what I think is what makes this so interesting, that each machine has the different requirements that you need to adopt to.
Yeah. Mm-hmm. Certainly with the travel function, you're carrying the full weight of the machine and all the batteries and all the other components on it. So it's a large consumer of energy, battery energy.
Thanks for your question. it's probably a bit of a touchy topic, but as far as cost is concerned, I don't know how much you can share with me here. Developing fully electric battery or hybrid system, do you have a comparison there? I think you mentioned at the beginning.
Well,
fully electric is actually quite expensive.
The most costly part of an electrified system is the battery system, and that's just the way it is. We all know that, and we work around that. So it really, as I said earlier, every machine is different, and every machine has a business case that it has to solve. So I wouldn't say one's better than the other. I would say an electrified hybrid system probably costs less because it requires less battery power. And it's probably we're operating at a lower power in general, so the components that we're using are probably smaller. So that's probably how I would frame it. But again,
So
every machine
in a very generalized
way.
Yeah. Do you have any experience? Anything you can add to that?
It's always difficult with the cost, but
Yeah.
one thing that is important, that is the total cost of ownership.
Yes.
So I think if you look at the full electric machine, a lot of the sales being done today, that is looking at the total cost of ownership. It's less components to change during the lifetime of the machine. It's less fluids and easier to maintain the machine. And
With
that is
a
a way,
hybrid.
both with a hybrid, I guess. The drawback with the hybrid is you have all these systems, but electric. So the total cost of ownership is something to look at for sure. So
Okay.
Yep.
Thank you very much for this overview of hybrid architecture and the things to consider. It's been a pleasure to talk to you both, Chris and Peter. All the best
Thank
for
you.
Bauma.
Great.
Thank
Thanks
you.
for joining me.
Thank
Thank you.
Thank you for your attention.